Good. Okay. So welcome everybody to the PhD defense of Fages. Thank you. So I'm Anastasia Vizorianos. I'm a professor here at the university. I'm part of the jury that will judge your thesis. I will introduce them in the interest of time afterwards during the question phase. So you have 45 minutes to present your work. And
thank you. So good afternoon, everyone. So thank you for attending this defense. My name is Arthur Fage. I'm working at the Listen, in the Exit team under the supervision of Cédric Fleury and Théophanie Sandlas. And today I will present you my work on collaborative design in augmented reality, and more precisely on how to support multiple views and parallel version of the design space. So collaboration is a key aspect of design. During the early stage of the design process, multiple designers come together to share their knowledge and solve design problems. For example, Thesis calls for the expertise of collaborators when they are stuck on a task. And likewise, experts help their less experienced collaborators when they are with the subject they know. In the architectural design, for example, a structural engineers will meet with an architect to plan the construction of a building. And in HCI practices, for example, interaction designers will conduct participatory design sessions in which they will brainstorm with end users and get that feedback, and also brainstorm about alternatives on system prototypes. As some design tasks often involve three-dimensional content, designers usually rely on physical artifacts to conduct their design process. In the automotive industry, for example, designers may use clay model to reflect on the shape of a car's bodywork. Likewise, the design of the inside of a car might be facilitated by positioning content directly on the 3D physical mock-up of a cockpit. However, the production of these models are complex and time-consuming. And also, they offer poor adaptability to design changes. Modifying their shape can be costly in time and effort. On the other hand, collaboration around physical objects require collaborators to share the same working space. And this can be problematic when designers cannot meet in the same place. Using digital 3D content solves some of these limitations. Designers can, for example, use digital tools to generate models on which they will control the appearance. Using computer-assisted design software, they can shape 3D shapes faster and more easily than using physical matter. Digital content can also be shared through the internet. Multiple designers can use this tool on their computer to collaborate around the same 3D content, but without being in the same physical space. However, the 3D virtual content, which is seen on virtual desktop, is limited by the lack of three-dimensional and in-context visualization. An approach to address these limitations is immersing designers in virtual reality. Virtual reality users perceive virtual content as they will do in a physical space. They can move around, they can be closer or further from the content. And designers can also generate or erase directly this virtual content using digital tools. With virtual reality, multiple designers can collaborate in the same virtual space. They can interact with each other, but also interact with the same virtual content. As Sutherland wrote in the Ultimate Display, there is no reason why the object displayed on the computer have to follow the ordinary rules of physical reality with which we are familiar. This is why previous work in virtual reality has already explored interactions independent from physical metaphors. The spatial geometry of the environment can be adapted to provide new form of navigation in space. For example, users can bend their surrounding to perceive or access distant location. Likewise, modifying the geometry of virtual objects can help visualize occluded 3D models. For example, the virtual 3D models can be cut and sliced until the part to access the occluded information. And virtual content can also be scaled, duplicated, and accessible through Portal. On this last picture, we can see collaborators interacting with a duplicated, reduced representation of a bigger virtual model. However, some of the objects of interest of 3D design require some contextual information, like how does it fit here? What can be done with it, or how did it get there? For example, architects might consider the environment, the physical environment around the building they are designing. As it was cited by Brian Lawson, the trick of a good design is to get an appropriate amount of order to meet the needs of the context and the situation. By combining elements from both the real and the virtual world, mixed reality technology bridges this gap between the physicality and the virtual reality. More precisely, augmented reality lets users perceive and manipulate virtual content while still being and seeing their physical surrounding. This technology can then help designers create and manipulate virtual content, but this time in context in the real world. In contrast with virtual reality environment, the virtual content in augmented reality needs to preserve its connection with the real world. Unlike the virtual world, physical objects are constrained by their physicality and cannot be easily scaled, duplicated, or their geometry easily altered. However, augmented reality technology also allows for pushing the limits of interaction design far beyond what is possible in the physical world. Physical elements, such as collaborators' hand, can be digitalized and be reproduced with a scaling effect elsewhere, point, for example, at location. In the second picture, we can see the use of virtual surfaces as cutting plane to unveil inside components of a physical system. And the virtual space overlaying a physical environment can also be deformed to bring virtual element closer or further while staying in the physical space. As stated by Mitchell et al., augmented place is not just virtual copies of physical space. They are the genuine outcome of the design of a new form of space, with qualities like plasticity and flexibility that are quite absent from the physical space in which we live. My goal and the goal of this thesis is then to investigate new interaction mechanisms for augmented reality designers to help them collaborate more effectively, whether they are working remotely or locally. Real-time collaboration is indeed a challenge when collaborators do not share the same physical environment. Such situations have become commonplace during the COVID-19 pandemic, but while video communication software supported many design and research teams to work together, modeling 3D content from a desktop computer with remote collaborators using an augmented reality headset still remains a challenge. Indeed, collaborators need to maintain a sense of workspace awareness, which is a sense of who is doing what, where, when, and how, despite their device asymmetry and their distance. But while sharing the same physical space can induce a strong workspace awareness, collocated augmented reality design might also be experienced through conflict and limitation. During ideation, for example, designers conduct a divergent process where they generate multiple ideas before doing a convergent process in which they will compare and select some of these ideas. The application of these divergent and convergent processes raise several issues when designers operate in the same physical space. First, they need to keep track of their previous creation so they can focus on expressing new ones before losing the previous ones. Occupying the space can also be a source of conflict between designers if they want to generate virtual content in the same location. And even if some designers may find inspiration by looking at other collaborators' creation, knowing that their creation are visible may be a source of inhibition. On the other hand, evaluating and choosing among existing 3D models require to access and search previously created models. Also, designers might need to perceive simultaneously 3D models that overlap in the physical world. And also, they might be able to import elements from one 3D model's version to another. So to address all these goals, I first investigated what are the dimensions on which collaboration with mixed reality is based on. Collaboration with virtual content can be experienced through multiple material configurations. The first one consists of using a traditional desktop environment, where users perceive a 3D virtual world through a 2D screen and rely on traditional computer inputs to interact with it. The second one is based on the use of augmented reality devices, such as tablets, headsets, or projectors. And the third one consists in using virtual reality devices, such as headsets or cage. But when users collaborate, they are not required to use the same equipment. The material configuration of collaborators can then be expressed through a dimension which is starting from material asymmetry, where all collaborators are using the same equipment, to end with the material asymmetry, complete asymmetry when collaborators rely on completely different equipment. Although some designers can improve their creativity by observing their collaborators' artifact, others might feel inhibited by the visibility of their creation. Indeed, public space is an intrinsic state of most of the collaboration with augmented reality. Each user sees the same physical as their collaborators, but also the same virtual space. However, the visibility of a digital space can be restricted to one user by defining what I can call private spaces. This dimension then considers the spectrum between having a shared workspace between all collaborators and having distinct private workspace between all collaborators. Collaboration using virtual content can also be considered through time. Collaborators can interact with each other in the same time windows, synchronously, but the collaboration can also be done asynchronously when they interact through recorded 3D messages. First, a virtual reality user realizes an action in its virtual workspace and record it. And then the collaborators can replay the scene and relive it without having the actual presence of his collaborator. This dimension then aims to cover the temporality of the collaboration, from synchronous to asynchronous interaction. The physical distance between collaborators is also a key dimension of collaboration. Collocated collaboration, when collaborators share the same environment, let them use traditional communication cues such as the voice, gaze, gesture, which allow them to maintain a sense of workspace awareness. But as we have seen during the previous COVID-19 pandemic, working remotely implies several constraints on this workspace awareness. This dimension then addresses the effort which is required to maintain workspace awareness from collocated to complete remote situations. Another dimension considers instead the representation of this workspace. Augmented reality devices augment the physical surrounding of their users, letting them perceive an overlaid virtual workspace on top of their physical workspace. But there is other way to do it. For example, rendering virtual content inside a camera stream video, letting users perceive augmented 3D content through a 2D screen. And finally, a physical workspace can also be reconstructed as a virtual model. Users can then perceive their augmented workspace, but in complete virtual reality. This dimension then explores the spectrum between augmenting physical space to using virtual reality to represent a virtualized augmented workspace. The last dimensions of this design space regards instead collaborators' view and their independence. Users can, for example, look into 360-degree video stream of a camera, which is placed on the head of their collaborators to perceive a remote workspace. They experience free navigation with the same viewpoint. But free navigation can also be experienced with various viewpoints. Users can, for example, freely navigate in a virtual reconstruction of a workspace to go from the view of a head-mounted camera to the view of another head-mounted or external camera. But the navigation can also be constrained to the number of available cameras. Transition between views can be absent, letting users perceive a workspace only from the viewpoint of the used camera. But while these configurations involve either multiple viewpoints or navigation freedom, the view of a workspace can be reduced to a single camera, providing only the collaborator's view. For example, by retrieving the view of a virtual reality headset on a tablet. The view independence can then be seen as a trade-off between two subdimensions that are the level of constraint in the navigation and also the available viewpoints. All these dimensions thus define a design space addressing collaboration with mixed reality. Mixed reality equipment can be symmetric or asymmetric between collaborators. Collaborators can either be close to each other or experience a certain distance, and their workspace can be fully public, fully private, or divide itself into partly private and public parts. Interaction between collaborators can be synchronous, or when it happens at the same time, or completely asynchronous, when action happens in different times. Workspace can be augmented, or on the other side, fully reconstructed. And finally, the view of this workspace can be dependent or independent between all the collaborators. To address the problems related to remote collaboration, I fixed some of the parameters of the design space to consider asymmetric remote collaboration, in which collaborators synchronously share the same public space. The remaining unfixed dimension then define a subspace of this design space whose investigation opens a first direction. To address the problems related to collocated collaboration, I fixed some parameters to consider instead symmetric collocated collaboration, when users perceive physical objects augmentation through independent views. I then open a second direction by looking at the subspace defined by the visibility and temporality dimensions. So I will first address the first direction and its associated subspace by investigating remote asymmetric collaboration. The following work has been presented at CLCW conference in 2022 and was also demonstrated at the French HCI conference, IHM, in the same year. So considering the impact of the viewpoint, the workspace representation, and the navigation control, we investigated 3 remote workspace representations. A fully virtual representation, a first-person view as provided by an augmented reality headset, and an augmented third-person view as captured by an external fixed camera equipped with a depth sensor. Our goal was to understand how do remote users perceive the trade-off of the 3 representations when they provide instruction to a remote augmented reality worker. To this purpose, we recruited 24 participants and divided them into 2 groups of 12 participants. Focusing on the viewpoint of the augmented reality video, the first group compared the headset view with the external view. And focusing on the workspace representation and the type of navigation control, the second group compared the headset view with the virtual view. For each part, we followed a within-participant design where all 12 participants tested both configurations. So participants were asked to place 30 pieces of different shape on a virtual board by giving oral instruction to the experimenter, who acted as a surrogate. Here, for example, we can see the external view perceived by a participant during the experimentation. The piece's position was given by a 2D top view pattern, randomly generated, and of course unknown from the experimenter. We then asked participants to compare this configuration on 6 different aspects of the collaboration. In this figure, we summarize the results of 5-item Likert scales that we use to evaluate users' preferences. On the left, we can see the preferences of the headset view versus the external view, and on the right, the preferences of the headset view versus those of the virtual view. We observe that participants see different benefits in each configuration. They appreciated, for example, the ability of the external view to provide awareness about the remote workspace and help them search and locate pieces effectively. However, most participants expressed another preferences for the headset view, as it helped them perceive their collaborators' action, facilitated communication, and helped them complete the task more effectively. The virtual view, in turn, was especially appreciated for helping participants to search and locate pieces effectively, but also complete the task more effectively than the headset view. By analyzing also participants' feedback and the answer to a questionnaire on preferences and difficulties, we obtained the following results. The external view main advantages appear to be the global awareness provided about the physical environment. Yet the orientation of this view requires users to perform a mental rotation. The virtual view in turn supports independent navigation, helping remote users to provide instruction from a convenient but also a stable point of view. However, this view is lacking information about the physical environment. Finally, the headset view seems especially effective for perceiving the actions of the augmented reality users and communicating egocentric instruction. But this view appears to be sometimes too shaky and can induce motion sickness. The external view was rated more difficult than the headset view for certain tasks, and this finding is somehow at odds with results of past studies, suggesting that the specificities of the task and the camera viewpoint may have an important influence to the success of representation. However, this result is in line with the work of Shepard and Metzler, who have shown that the time needed to perform a mental rotation in 3D space linearly increases with the angular offset of a viewer's viewpoint. However, the external view is the only configuration that allows remote users to see the face and the real full body of their collaborator. So based on the results of these first studies and users' feedback, we considered 2 design goals. The first one was to combine the 3 views while providing free transition between them. The combination was suggested by many participants. And secondly, to provide tools that minimize communication effort and facilitate coordination. This design goal was also motivated by participants suggesting features to indicate location or point at specific position. So to answer this course, we designed a multi-view remote collaboration system that we called Argus. With a lateral button of its main interface, Argus provides a quick way to switch between views. For example, by clicking on the external view button, the main view will switch to the external view. And similarly, by clicking on the headset view button, the main view will change to the headset view. Switching to the external view or the headset view can also be done by clicking on their 3D representation in the virtual scene. So for example, by clicking on the 3D headset, the view will switch to the headset view. And likewise, by clicking on the external camera representation, the view will switch to the external view. At any moment, Argus also offers the possibility to display live previews or full previews by hovering the view buttons. This mechanism aims to prevent the short burst of switching between views. Preview can also be displayed by hovering the 3D representation of the headset or the 3D representation of the external camera. To ensure visual consistency among views and avoid disorientation, we used a trajectory and field of view interpolation to animate the virtual camera in the 3D scene. So Argus allows transition between viewpoints by clicking on the view button, but users can also click on the 3D representation to perform these transitions. To facilitate close inspection of specific parts of 3D models, we integrated into Argus's user interface a spherical view tool. These tools can be activated either within the external or the virtual view, and users can then move a virtual camera on the surface of a sphere to show a camera preview. Users can keep the current viewpoint or also use these tools to switch to the preview camera position, as you will see in a few moments. Argus also provides a virtual stick control with a mouse. A preview of its tip is displayed to help users perceive more easily depth and understand where the stick is pointing at. And in all view of Argus, remote users can use a virtual stick to add annotation, which are represented here as colored sphere. Technically, Argus received the augmented video stream from both an augmented reality headset and also the video stream from a Kinect V2, which are located both in the augmented reality user's workspace. To generate the virtual view from any workspace location, it maintains a synchronized version of the virtual 3D scene and also the headset hand and hand tracking. More technically, on the local side, the augmented reality headset is connected to a server using a client and the UNet library. The server synchronizes the virtual scene in the augmented reality headset, but also render it into the Kinect video stream. The calibration between the devices is made manually for the augmented reality headset, and using Apple Tag Marker and the Vice library for the Kinect. The application of the remote user is also connected to the server as a client using the WebRTC protocol. We built a custom protocol on top of WebRTC to synchronize the 3D scene and use mixed reality WebRTC libraries to convey the video stream between the local setup and the remote setup. We then conducted a second user study to investigate how remote users will use Argus's features. We then searched to observe how remote users will navigate between Argus's views and assess how they will use the tools to communicate instructions. To answer these questions, we recruited 12 participants and considered two configurations, a headset view only without any interaction capability and Argus. We used the headset view without an interaction capability as a control condition, and we followed a within participant design where all 12 participants tested both users' interface configuration. We decided this time to focus on a furniture arrangement task, requiring participants to search for miniature furniture in the workspace of the experimenter and place them in a 3D house model. We introduced several constraints for this placement using symbols that was displayed on the wall of the 3D house model. Participants were asked to arrange furniture for 3 thematic spots, randomly chosen among 9, and with respecting these constraints. Based on previous studies, we expected Argus's users to find the multi-view transition and tools useful, perceive the verbal communication as less important, and to communicate instruction with less words. We segmented the collected data to see the use of the virtual view, the use of the external view, and the use of the headset view. Overall, we can see that all the participants frequently transition between all views, which demonstrate the utility of our approach. Nevertheless, the virtual view and the headset view dominated participants' choice, as we can see with the green and the red rectangles. We observed that several participants extensively used the headset view in a preview mode for the virtual view. And this is particularly the case for P4, P9, and P11. We also observed that the stick and the spherical view tools were also used, as shown by the colored rectangle on top of each floor. For example, P1 and P3 regularly use the stick from the external view to indicate furniture pieces, and P4, P6, and P12 also use it in combination with the virtual view, but this time to indicate target location. We again used 5-point Lakers score questionnaires to evaluate the perceived efficiency. Participants rated Argus as more efficient than the headset-only configuration. According to P6, the headset view causes seasickness, and P9 commented that the resolution of the frontal camera of the HoloLens can be limited. However, 7 participants rated the headset view as more efficient for helping them to perceive the workspace of their partner. Sorry, as P3 said, having only one solution forces to use it, and in the case of the headset, forces to establish an efficient communication with a partner that can be lacking when all the other configurations, all the other views are used. We also asked participants to rate their perception about the importance of verbal communication. Overall, the verbal communication was perceived as less important for Argus, particularly for describing which pieces of furniture to take and where to place them. It then explained that verbal communication is more important for the headset view because you cannot point with as much precision as with a stick. We also transcribed audio recording during each session and count words pronounced by participants. We identified words used for instruction and classified them whether it was to manipulate, to identify or reach objects, or ask the participants to move around. Overall, the Argus user's interface reduced the number of words that belonged to instructions. Surprisingly, further analysis showed no clear differences in the number of words used by participants to either guide the experimenter to identify, reach, or manipulate objects. A possible explanation of these results is the fact that 5 participants did not at all use the stick and relied instead on verbal communication. Overall, our results confirm that remote desktop collaborators can benefit from the multiple views of Argus, since each view is best adapted to a different aspect of the task. Given previous results, we still expected a more extensive use of the external view. Maybe finding another viewpoint for the external camera could further be explored, and solutions like the one proposed by Gusti and Hall can be to move the external camera on the flight during the collaborative task. We also found that Argus reduced the average number of words for remote instruction, which corroborate with previous results from Billingers and Hall, that increased view independence reduce the prevalence of verbal instructions. We, however, analyze that all experimental method and setups present several limitations. The first limitation is that the experimenter took the role of the local collaborators in all experimental sessions, which limited the external validity of our results. Also, the variable quality of the internet connection and the limited resolution of the headset frontal camera may also have had an effect. In this work, to summarize, we studied how different views can help remote desktop users to collaborate with the local user who is wearing an augmented reality headset. We presented a first study to explore and understand the trade-off between 3 view representation, and based on the result of this study, we developed Argus, a multi-view remote collaboration system with view transition and pointing annotating tools. We then ran a second study to evaluate how Argus supports remote collaboration in a furniture arrangement task. So now, to cover the second subspace of the design space I previously presented, I will now focus on the second direction, which was addressing collocated symmetric interaction. The following work was presented at the HCI French conference, IHM, last week. In this section, we will consider a scenario where 2 clothing designers, that I will call Gabriel and Carl, use 2 augmented reality headsets to ideate on the creation of a jacket by drawing 3D content around a physical sewing mannequin. To address the issues related to their collaboration, we created a conceptual framework that allowed them to ideate around the around the 3D model, which is superimposed on a physical object, and framework that I will now describe. To generate and represent ideas, Carl and Gabriel can create or delete 3D ribbons by using the index finger as pointer and a mouse or external device to activate these tools. They can then create jackets model around the physical mannequin in the form of 3D sketching. Our framework allows them to capture the different state of their virtual space at user-defined times in the form of version. And to make it easy for users to manipulate and perceive this version, we reify them into version objects. So when Carl or Gabriel want to save the state of their 3D drawing, they can generate a version object. As you can see on the screen, a version object is represented by a spherical shaped virtual object, about 20 centimeters of diameter, and that contain a preview of the 3D model in the version it reify. The commands related to its use are placed around it, and also allow to use the feature. Also allows the feature that will be detailed in the rest of this presentation. A version object is created from the virtual content that is currently visible to a user, for example, with an input gesture such as grabbing. And the creator can then move it in space and arrange the workspace with all the version objects that he have or she have created. This feature can be used to save the different steps of creating a 3D model, but can also be used to save a 3D model before modifying it and creating an alternative. Version object can also be used to navigate between views and place a user's virtual space in the state corresponding to the version they reify. All the version object visible by users thus define possible alternatives to his virtual space. When a user wants to change version, he just has to move the corresponding version object and apply it in its working area. In this way, users can revert his or her virtual space to a previous version of the virtual content, switch to another version, or create a new alternative. By default, the version objects are visible only to their creator. This allows to keep a kind of confidentiality of the design, which can be beneficial for creativity. And the designers who created a version object can also choose to share it with the collaborators. And of course, this sharing can be stopped at any time. A version object can also be used to generate a preview of the augmentation it represents. It can then be compared to the currently displayed version. And when the user generates a preview, it adds the element from the virtual space reified by the version object inside its virtual space, but with a game of color and transparency to differentiate the two versions. However, a preview can be inefficient if the 3D models of the two versions are overlapping. And in this case, we propose to users to generate a 3D portal. A 3D portal is defined by a volume that allows two versions to be displayed, respectively inside the volume and outside the volume. A user can then compare two different 3D models by playing with the size and the position of the 3D portal, and this can be compared with a slider comparison between two overlapping pictures after default. Another feature of this 3D portal can be the ability to import elements from a version into another by selecting the ribbon inside the portal and adding it to the version outside the portal. 3D portal then induce a kind of porosity between the virtual space in which the user is currently located and the virtual space that are represented by version objects. In this video, we can see that the volume used is a sphere whose interior corresponds to the virtual space of the version object and the outside of the version in which the workspace is located. As we have seen before, the created version object allows users to move between different versions of their virtual space. However, if a user wants to change his or her virtual space, it's not necessarily the case for the collaborators. For example, if Gabrielle wishes to momentarily explore a different idea from Carl, she should be able to do it without being hindered or without interfering with Carl's creation. To do this, we propose to desynchronize the virtual space. Carl's virtual space thus become different from Gabrielle's virtual space, even if they still share the same physical space. And this mechanism can, for example, be used to explore different design ideas or to enjoy privacy in private space. When Carl and Gabriel want to work simultaneously again and share the same content, they can resynchronize their virtual space. Both collaborators need to authorize this synchronization to make it effective to maintain confidentiality. And when the workspaces are resynchronized, Carol then perceives the same virtual space as her. In order to make this scenario possible, we have implemented a system based on the concept of the framework. This one is based on two HoloLens 3 reality headsets in which applications developed with Unity are executed and communicating between both using a WebRTC protocol and a Wi-Fi network. However, this work also presents limitations. We considered first only 2 people equipped with augmented reality headsets. If other augmented reality devices such as projectors are used, the framework might be inefficient, especially for the desynchronization of the virtual space. On the other hand, the handling and organization of version using version objects, as well as the concept of synchronization and desynchronization, can be perceived as complex and unusual for users. Users' behavior in this conceptual framework has not been evaluated yet and require further investigation that could be conducted in future work. Also, easily retrieving version and switching between them might induce a deconstruction, a reorganization of the design process. Users might parallelize some tasks that are usually done in a sequential way. So to summarize this project, we studied how collocated augmented reality designers can versionize their creation and particularly fully desynchronize their virtual space to compare them. Using version objects, collaborators can verify and manage the state of their virtual space by manipulating virtual three-dimensional objects. We then proposed a framework based on these version objects, who allows designers to explore simultaneously different ideas and enjoy privacy during ideation. So to conclude, this thesis explores new way of enhancing collaboration using augmented reality technology. The aim was to expand the boundaries of interaction design beyond what is achievable in the physical world, with a specific focus on collaborative tasks. To this end, I first established a design space whose dimension cover equipment and distance between collaborators, but also the visibility, the temporality, the representation, and the view of their workspace. I first explored the subspace related to asymmetric remote collaboration in the public synchronous workspace. I focused on the issue raised by the workspace awareness of remote users, and I argue that combining multiple views with various workspace representation, viewpoint, and navigation control may address these limitations. I then investigate the subspace of collocated symmetric collaboration when collaborators have independent views of their augmented workspace. I focus this time on the versioning and the privacy issues that rise during collocated collaborative tasks. As augmented reality enables users to see and interact with multiple virtual spaces while being in the same physical space, I argue that bringing this insight into the context of collaborative design can help to address these issues. This exploration led to several contributions. The first one is a theoretical contribution through the conceptual framework that I presented before. With this framework, collaborators can create and interactively manage versions of 3D content in their workspace using version objects. These frameworks also provide tools for navigation and comparison among versions by desynchronizing and resynchronizing collaborators' virtual spaces. Collaborators can then go beyond the physical principle that an object should exist only on one site at a given time for everyone. This thesis also introduced technical contribution. I presented a system that applied the concept of the previously mentioned framework to collaborative 3D sketching. This system implemented version object as 3D virtual object, letting users manage version of 3D content through partial or complete desynchronization of their workspace. I also introduced Argus, a multi-view remote collaboration system that helps remote desktop users to collaborate with a local designer who is wearing an augmented reality headset. These systems provide tools for effectively switching between the different representations of the remote workspace, virtually navigating in the space, but also pointing or annotating 3D content. Finally, this thesis presented also empirical contribution. I reported on the result of 2 user studies. The first one explored the trade-off between different workspace representation, viewpoints, and navigation control. And the results of this first study informed the design of Argus. I then conducted a second study that observed the use of Argus and compared it with a common configuration where remote users only have access to headset view without any interaction capability. This work would, however, benefit from additional investigation. First, the two conducted user studies only consider the perspective of the desktop user during a remote collaboration with an augmented reality headset user. For example, the representation of the desktop user in the augmented space could be further investigated, as well as all the awareness cues of the desktop user. The framework addressing collocated augmented reality collaboration has not been evaluated. Some research questions remain open regarding how collaborators will understand this concept of synchronization and share their workspace or adapt their design process. Another direction for further research is to consider multi-users interaction with more than just two collaborators. One of the key challenges, for example, in a remote setup is how to represent each user in collocated augmented collaboration. An important issue would, for example, be to determine which collaborators is synchronized with which and how to represent the state of the framework for each collaborator. A dynamic reconstruction of the physical workspace could also be investigated. Such reconstruction could enrich the remote representation of the workspace in the virtual view of Argus, for example, by including virtualized physical objects. Using physical space reconstruction could also extend the versioning beyond just the augmentation by considering physical object, virtualized 3D objects, physical objects with their augmentation. Finally, further investigation could explore how multiple desktop users could collaborate with remote collocated augmented reality users. Features from both Argus and the framework developed in this work could be combined to manage the creation of 3D and the management of 3D sketches in remote augmented reality collaboration, for example. And this could be a first step to expand content creation beyond traditional CAD desktop software and open new design opportunities for existing augmented reality systems. Thank you for your attention, and I'm not sure this will work if you have any questions.
Thank you, Abdul. So I suggest that we start with each one of the jury members for about 15 minutes of questions. If that's okay with you. So it's customary to start with the two rapporteurs for this thesis. And I will start with the person who came the farthest away. So Ferran Argeliaguet, who's associate with research at NPR.
Thank you, Mr. President. So first of all, I would like to thank for the invitation of being here today. So it was really a pleasure to read the manuscript and also to assist with the defense. Thank you for that. Also, would I just provide some appreciation of the presentation? So I found the presentation was really clear, well structured, well illustrated. I think we did a nice job presenting different contributions and structuring. I really like this design space you presented. It really provides a nice view of all the, provides a canvas to present your works and also provides a nice overview of all these challenges that are raised by the collaboration. So I'd also like to highlight that in your PhD you have several contributions as you illustrated well, like this scientific contribution, research contribution regarding the frameworks, the technical contribution of developing these such complex systems, plus all the experimental parts. So congratulations for that. And now let's go to the tricky part. So I have a lot of questions, but then we have 15 minutes, so we can be brief. So first, I will start with Argus. So regarding your second contribution. So let's start with something really simple. So in one of the main tools you have in the system is the stick, so you can point towards some specific objects. So I did a demo, so I will tell you for that. And one thing that I was a bit strange for me was the origin of this ray. I mean, how you display a ray plus perfect timing.
That's a question.
I will say okay. So I'm basically, and you control the ray with the mouse. So why displaying this ray exactly? So what was the purpose?
Do you mean in the virtual space? Or
yes, when you're in the virtual space, you can use this this ray to pinpoint that point in the environment.
One of the idea was to provide first awareness cues for the desktop user or the augmented reality headset user to see if, for example, a point is occluded by the 3D model or not directly visible from the augmented reality headset user. The direction of the stick, the representation of the stick can help to see where the remote user is pointing at. And this is one of the reasons. Also, another reason could be that we try to represent a physical metaphor of the stick, like not just a pointer, also the full representation of I have an object that I can move inside the virtual space.
And the ray has no relationship with respect to the AR user, or there is some.
No, the virtual stick is fully controlled by the desktop user.
Then also an interesting thing of Argos is this combination of multiple views, and you have already somehow discussed this a bit. So how many views is enough? I mean, you had like 3 views, so there is a trade-off.
Yeah. One of the main motivation of Argos was to avoid the technical complexity of reconstruction. There is other work in the literature that instead focus on reconstructing the physical workspace and its augmentation, but this requires technical complexity and also required high bandwidth that we wanted to avoid with Argos. Argos, for example, was studied during the lockdown with remote participants using classical internet connection. And this was a kind of requirement not to use more than just Dribble. And from the first study, we can see that this can be enough to conduct some tasks like the furniture arrangement task we introduced in the second study.
I have 2 comments in this. So first, I mean, so one issue is a reconstruction. So I can agree with you. So reconstruction is hard. We'll get at some point. And the second is bandwidth. I mean, you already have 2 video streams, so that is already, let's say, bandwidth which is not negligible. So I think the one I agree. Okay, reconstruction is hard, but there's a bandwidth. I think.
Yeah, it can be.
You have that video stream, but I mean, it's I kind of. Then I also have just another regarding the multiple views. So something that I see when I was testing the system, that I mean, it's demanding to switch for views, and because you need to manipulate a lot. Have you considered to have this juxtaposition of views? So I mean, why? I mean, I guess that for your experiment it was easier to have one screen because I mean, your remote users probably don't have 3 screens at their homes. But being the ability to, I mean, just switch the view by moving my head instead of trying to control the parameters, this can to your mind or
not directly, and this could be further explored indeed. We did something between both with the preview using the ability to display only 2 views, but 2 different views in the same interface. The design of Argos was mainly inspired by the feedback of the first study, and the main idea was to combine the view, but also use each view for certain aspect of the task, because at some point during the task you will enjoy having a wide view of the physical and the virtual space, and at some point you will just have to be on top of the 3D model without any physical information. And so the design of Argos was followed this insight that one view could be used at one point during the task. Did not consider having all the tasks at the same time. And this makes me also think we didn't consider the cognitive load of the participants, but this could affect the cognitive load having all the views simultaneously displayed. So this needs further investigation, but this could be an argument in favor of Argos and having only one view to consider one aspect of the task.
I'd say that my cognitive load was high trying to switch between views.
We need investigation.
And then something that I came to my mind, I mean, when I was reading the manuscript and I see the pictures, said why they didn't mirror the video feed.
There is a reason for that. That is the consistency of the transition, of the spatial displacement during the transition. Because if we mirror the external view, we cannot. There is a breakdown during this transition, and this can be confusing when switching from the external view to another view. On, for example, the virtual view.
Why not mirror everything? In this case.
This also applies to the headset view. And, for example, if you want to give indication, the object on your right hand, the object on your left hand, this can be confusing if you mirror the headset view, for example. So, and also it requires mental rotation, but it also maintains spatial consistency. The representation, the mental representation of the workspace.
I think that's one of the reasons that in most of the cases you have this over the shoulder camera. Somehow you're allowed to, okay, left is left, right is right, up is top, down is down. Because I mean, I think I need to move. I mean, I read that on left and right. I think a lot. So I understand that it's not the evaluation. Okay, so I want like all the there, so I will move around. Sarah? If I still have time, I will go back. It's fine. So now let's move to the second part regarding the version of the object. So first here I have one comment. So at the end, the physical object is shared. Because, I mean, I guess your initial objective is that the physical objects of the mannequin is shared.
Mm-hmm.
So I mean, this creates some fight for this resource for the user, because I mean, it will be difficult for them, like both trying to design at the same time. And I wonder if you thought about this, or what is your...
This is something that could be investigated. As I said, we didn't evaluate, we didn't conduct any user experience with the framework, and this is fundamental to see users using the co-creation with physical and virtual content. What inspires us was this ability to have different workspace, virtual workspace for each other while being in the same physical space, and to explore this augmented reality principle, if I can say that, in the co-creation. But yes, of course, if two persons want to put their hand in the same place, it will be a conflict. But we can avoid all the conflict of the co-creation by having two different canvas overlaid with this desynchronized virtual space. So this is more a question about territoriality, which have not been considered yet. I would love to conduct further investigation around this work, and especially with professional designers and the current usage of co-creation. But yes, this remains a conflict. Another solution could be to, as I said at the end of the presentation, to reconstruct the physical space and immerse virtual users in this virtual reconstruction, and having the ability to teleport elsewhere and still having a perception of the physical space. But this is a completely different work and another research direction.
It's also something that I mean, just a comment. So I mean, I see there's a lot of works in AR which they don't push a lot what you can do with this physical space. So in your case, you have like, you put everything on the mannequin. So this is the central piece. But I mean, why not having two mannequins and to have some territoriality? I mean, I work in my mannequin, and when I want some help, okay, I ask the other person to come, and if they come, they see what I'm doing, and to also leverage a bit this capability of move around.
So I think it's related to tasks where it's hard to duplicate, to have copies of physical artifacts. For example, in this scenario, the picture showed a blank mannequin, but we can imagine a mannequin with already pieces on top of it, and unique pieces. And in this time, you cannot duplicate easily these pieces, and this is where you need co-creation in the same space. And this framework aims to address this situation in particular.
And then I have also some regarding similarly like this. So I mean, I could try the system, and I mean, at the end, you end up maybe creating, of course, you could playing around, and you end up making a lot of different copies, and it's all over the place. And somehow you might, I mean, if you have several users running around, I mean, they will start and jump, I mean, going over your virtual creations, I mean, running around, and yes. I guess at some point, so it's really nice to have this concept of desynchronization. But by doing this, you also start maybe going at the wrong place because you are not aware. I mean, I don't know your thoughts on having solutions? Or, I mean,
Exactly.
what have you experienced by testing the system?
I don't have any experience. This is a point, but yes, and another possible observation could be that people will avoid some area knowing that possibly there is something which have been made by the collaborators. So having the awareness of the desynchronized virtual space is something that indeed could be considered. This territory and space organization. Yes.
There's some a bit more general question, but I think it's more related to this last one. Is about the actual interaction capabilities of augmented reality. So, what is your thoughts? I mean, you've been playing with this technology for a while. So, what works? What doesn't work? Your thoughts in terms of interactivity. So, what
In terms of multimodal.
yeah, or like pushing buttons, drawing. So, what do you think is working? And what do you think is...
My opinion. I think we need to keep tangible interface in the whole process of designing interaction, because media interaction is very abstract, and the absence of feedback, for example, is very, I mean, in my opinion, it's a bit disorienting. Maybe in the future people will be used to it and it will be okay, but for now I think it's important to have something tangible. And yes, for example, in the second project, we used a mouse or small keyboard to activate the tools, and I find it very useful instead of having just a pinch to draw. I don't know where it's coming from, but I think it's interesting to keep something physical, tangible interaction with augmented reality.
Maybe the last question. It's more philosophical. Imagine that you have like this magic wand and you can solve one of the problems that for you it's really hard, and this is the critical thing of what you've been doing. So what would be this critical problem that you think?
For augmented reality?
Yes, so for the work you've been conducting. So what do you think is the thing that requires?
The quality of the augmentation. Because right now, for example, with the HoloLens, you have the chance to test, you have a screen which is here, so your eyes adapt to the screen and also adapt to the rest of the environment. And this is, it requires effort, and this gives a sense of, okay, this is virtual on top of the physical. And I think I would be very intrigued by the ability to have something which is not physical, but can be perceived as somehow physical, to be able to say, no, it's not physical, but having this fidelity in the virtual representation. And it could be interesting to avoid side effects that we are currently dealing with in experimentation and interaction development. So, yeah, I guess.
Thank you. We have some time afterwards.
We still have some time if you want. If you have one or two more questions, otherwise we can do second round.
2 seconds. Okay, maybe last one. Going back to Argus. So I think it was really nice. So I really like the way you did for having this timeline of what the user is doing. Basically, with different interaction they were doing. So they were using.
Oh yeah.
Which view they were using and so on and so forth. I was wondering specifically on the virtual view. Did you observe some pattern in how they were orienting the view? If they were keeping some, trying to align themselves with the actual user, trying to replicate this over the shoulder view, or they was all over the place.
I have two elements to answer this. The first is from the first study, where users in the virtual view automatically, most of the time, put the view like the design pattern, like the solution of the puzzle. And this was, a lot of time. Users did this transition that, okay, I have this frame of reference, I will have the same view in the virtual world. And in the second, it was not the case in the second study, and I think it's dependent to the task, what you are asking to users. And the virtual view was more used to navigate inside the 3D model, not to follow the user or to be close to the external camera. It was mainly to get close to something or to move rapidly from a point to another, as far as I know from the research.
Thank you, excellent. We're right on time. So the next rapporteur for the thesis was Eric Asias, who is a professor at the University of Lille.
Thank you. So first, I want to say I'm very happy to be part of this committee. So thank you, Thesis, for the invitation. Also, I really appreciated your presentation. So it was very clear, dynamic, well illustrated, and it was on time. So great. I also liked reading the manuscript. It was well written, so discovered things. Was great. And this morning, I really liked the demonstration. I like coming to PhD defense, especially when there are some demos, and it was great to try the demo this morning. And also, I had the chance at EHM 2022 to try the other demos that we did not try this morning. So I remember I liked that demo as well. And also your PhD is something very coherent. There are some PhDs with works that are not clear what is the relationship between the different works. For you, it's a very coherent PhD topic. Also, I've been really impressed by the technical developments, all the prototypes, and this morning there were some demo effects, but it's the day of the PhD defense, so it's normal. But your prototypes really work because you managed to run some evaluations with remote participants. So I mean, to make that working, it's I guess it's not that easy, and especially given that you use different technologies, so AR, a lot of technologies, so there's always something that can break at some point. So that's something I find impressive in your PhD, and also the user studies and their analysis. So that's I find well done. So now it's the time for questions. I still have to questions after all the questions asked. Maybe a first question about the title of your PhD. So if you can go back to the first slide.
Yes.
Yeah. Yeah, so the second line, so supporting multiple views and parallel versions of the design space. So in HCI, design space has some meaning. So as you described at the end of your introduction, and so here I guess it's a different meaning. It's more in the meaning of the workspace, design workspace, I guess.
Yes, exactly. But the idea was to kind of contracting design workspace, design space,
Okay.
having a space of creation, but for design.
Okay, so it's more in the sense of design workspace, because I was wondering if I missed something in the title.
No, it's more design workspace than design space as a way as.
So in some ways it can be a bit misleading. But,
okay.
It's a point going on. So then I'm going to jump to some questions about Argus. So you have two experiments, and the task is different in the two experiments. So I was wondering why not using the same task in the second experiment as the first experiment. So why two different tasks? What is the main reason?
The idea of the second study was to consider both virtual and physical objects. In the task, the furniture arrangement task, there was this virtual 3D house model and this little miniature furniture, physical object. And it seems interesting to evaluate this system beyond the task of having just an abstract task of doing a puzzle. And, having to search for pieces in the physical space was not really something fully explored in the first task. In the first task, the research was only virtual content, so it was.
Yeah, but you could have used, I don't know, some wooden pieces.
Yes,
for
but
the second experiment.
for example, the virtual view, physical element in the virtual view limits this view, and it was interesting to tackle this view with physical elements that are not visible in this view. So this was something that appeared interesting to evaluate for this view with our system. Yes.
I mean, it was more for curiosity. The two experiments are nice. But,
No, but you're right. It's an interesting question, and I have a second argument, which is the dimension of the content of the task. For example, in the first experiment, it was just a 2D pattern. I mean, the pieces were in 3D, but the area of interest were visible in 2D. In the second design, there was a wall with symbols, and some of them were occluded depending on where we were looking at. And this is more interesting to consider the placement of physical object with these symbols rather than just having a 2D working area. So I think it's an additional element.
Okay. I was wondering about the design choices for Argus. So there's this way of switching between the different views. So after different experiments, what would be the main thing to improve about the system? What was the most difficult?
I think the spherical view could be further. We could think more about the spherical view because this tool was less used than the stick and was maybe too specific to the task. I think it could be interesting to investigate more how it could be used and how it could be made easier to use. I think this is something that can be the limitation. Also, the control, maybe we could use different input devices to control the transition between the view, because the way we implemented the command, it was a reference of most of the 3D creation tools, 3D digital tools, like I'm moving forward, I'm moving around. Maybe we could use, I don't know, a manipulation of, for example, using motion and the ability to move in 3D, the hand to move around, or investigate other inputs method to navigate inside the 3D.
Okay.
This requires further work, of course.
And so currently it works with 2 users.
Yeah.
So what would be the main challenge? Not from a technical point of view, it's a bandwidth and so on, but from an interaction point of view, to have more than 2 users, so you can have different desktop users, say, and also you can have different users with augmented reality, so could be collocated or I don't know, at different places.
I think the main problem will be the representation of each user, because right now, and we study only this part, so we didn't really get into how to represent the desktop user, but if there is more than one desktop users will have to see each other. I mean, this could be useful in the task and just to improve the awareness of what is happening inside the workspace. So I think, this is the main concern, their appearance, but also the indication of what they are doing, which tools they use, etc. Maybe also some occlusion problem may appear. For example, if I'm doing something, the 3D model is here, and another user is getting between the model and my virtual camera, it can be something that needs additional interaction, for example. So yeah, I think it's a main concept.
So I also like the other contribution about the drawing and the creation of different versions. One thing I was wondering is, so currently you do everything using augmented reality. And for example, when I create a version, so I tried to demo this morning, so I created one version, second version, I had three versions, and then it was not very clear which version I would like to use later, because, for example, I cannot provide a name or a comment to these versions. I was thinking, though, I would need a keyboard to type some text, to enter.
Right.
That would be great.
Yeah.
And then I was wondering, yeah, maybe I could combine like a desktop computer with an augmented reality headset.
Mhm.
So do you think that would be some opportunities that would be interesting, or do you think it's better just to stay in augmented reality all the time?
I think this is a good opportunity for multi-devices configuration. For example, from your example, I was picturing an augmented reality headset using a tablet just as a painter tablet to select the color, the size of the ribbons he or she is drawing. And this could also be used as a tangible interface with the keyboard, for example, to type text and name, for example, the version, or just to serve as, I don't know, a container, for example. You can have a version object as a 3D object or as a 2D component on another surface, another workspace, which can be either public or private. So, yeah, you can extend the workspace to other devices such as the tablet or the desktop, more physical. So yeah, this could be investigated.
Because so in that framework, so you explored a lot of things. So this notion of creating different versions and comparing the versions. But I don't know. We need to run some user experiments. But my feeling is that it's a bit complex for a normal user.
Yeah, I agree on that.
So you would need to do some simplifications. So what do you think would be the simplifications?
I think, as you said, the management of the version object, the ability to, right now, for example, we let the users define collections by organizing in space the version object. So the user is completely free, and this can be an advantage, but also problematic, because as you have done during the demonstration, you create a version object, then another, then you have a kind of cluster of objects, and it's really hard to see which one corresponds to which version. So one thing could maybe be to define area in the workspace that are specific for, I don't know, a moment in the creation, a step of the design process, or just a folder for putting objects inside. The other could be to represent the causality within the version. This is something that I've not been exploring in this work, but to represent the link, the temporality of creation of this version object. Not, for example, all the time, but to have, I don't know, for example, a feature to highlight momentarily the relation between the version could help to say, oh, okay, this is a fork of this one, and I was working on this one, and then I create this one to retrieve more easily each version. So, but this is another work, which is how to represent timeline, or how to represent time organization. But this could be, yeah, simplified.
We've got time for last question. So I guess with that work, your assumption is that it's going to improve the process of creation compared to traditional process.
Yeah.
So among all the features you provide, which feature do you think is the most important? What this, to help the process of creation?
It's more complex, but I think the desynchronization of the virtual space between collaborators and augmented reality can really help the design process, because it's not something you can have elsewhere. It's really a specificity of augmented reality. To use it to define canvas, to define, I don't have a word in English, layers that you can see, for example, in computer-assisted design like Photoshop, you have layers of pictures. But in 3D, this concept of layers, it's a bit abstract. And overlaid layers, it's even more abstract and impossible to use without this desynchronization, where you can select which layer you are in, especially in a collaborative scenario. So I think this is where augmented reality with headsets, of course, in this case, could be interesting to go beyond what is done actually with conceptual.
Time for tiny question.
If it's a tiny question.
It's a tiny question. So it was about some figures. So I like the stats you presented and with the Bayesian approach and the credible intervals. And in the figures, you represent standard deviations of the error bars. Why not representing the 95% credible interval instead of the standard deviation?
The idea was to compare to configuration. So this is, I mean, I think I have a slide where this picture you're referring is displayed. Maybe.
Because, I mean, to my point of view, I'm not an expert in Bayesian stats, but So yeah, for example, you represent standard deviation. So why not the credible intervals for the error bars?
I'm sure to get the question.
I mean, it's like, so when you present, so with confidence intervals, usually the error bars represent, you do not represent the, you could represent the standard deviation, but usually you represent the 95% confidence intervals. Here, yeah, it's not clear to me why you represent standard deviation and not credible intervals. You can use a joker if you.
Yeah, I think I will have to reflect on that, but I would love to continue the discussion on that. Yeah, sorry to be about to answer right now.
So now we'll move to the rest of the jury members. So we'll start with Morten pronunciation. Hope it's good. He's a professor at Chalmers University of Technology in Sweden, and he lives here for
Yeah, thank you.
I was looking for you.
That's okay. I come from the north, so you must be that direction. I still want to stay on a chair. I'm not standing here, but can you give me a chair? Actually, that works. All right, thank you. Let's see. Alors, merci beaucoup. Alors, dans les pinodiques, normalement, ceux qui opposent, ils amènent leurs prestations sur des PowerPoint et présentent les questions comme ça. Alors, je vais le faire de la même manière aujourd'hui. Je peux prendre des questions ou des commentaires en français, mais je vais continuer en anglais. Merci. Okay, thank you very much, Otto, for great demos this morning. And you see me there, I was very impressed. And it shows that it's AR because the person doesn't have a headset, doesn't only see the physical props. That's great. Thank you very much.
Thank you.
Very revealing to see your demo this morning. So my question will be mainly around the last paper, which is section 4 in your PhD, Collaboration Beyond Physical Proximity, which is also a very solid and substantial paper. This also shows the rounding off of your great work. And I'll also have some questions, quite a few about the introduction, which I really appreciated, and then a few questions about the other
sections, and I'll try not to be longer than the other opponents here, so I'll move quickly. So first, a few observations. I mean, what you mostly study is AR, where users do not have to move that much. They're at the table or they're next to the design puppet. Is that right?
Mhm.
So I'm not saying that this is desktop AR, but there is a term called desktop AR, which actually evolved long before that there were headsets on the market, and you see a little sequence of evolution here from 2002, 2007, which is a paper you cite. I wanted to get the cursor there.
Yeah,
And then some more recent stuff. So you might consider to cite that kind of work. Yes. And then some other comments here. It's promising that you talk about 3D prototypes and artifacts, but it seems, that's maybe I misread, but it seems that you don't come back to those terms. So you might include those terms in your discussion to make like a poem, like a bridge over your work. That would be nice.
Okay.
And you see links downstairs. Now something else. Yeah. So you also talk about the Milgram AR/VR continuum. It's called something else, called Milgram's continuum. So yeah, that's very, very good, very meaningful. So did you do, I think we got the question up here. Did you do some of your prototyping in VR, which maybe could be less expensive, or does Unity, is it kind of say, is it, I mean, it's both AR, VR. So is this a meaningful question, or could you do some of your prototyping in pure VR, or did you do it all in AR?
I mean, technically it's the same
Yeah.
development process.
Sure.
If you accept the building process, of course.
Exactly.
So in a term, yes, but it's still really dependent on. I mean, you want prototype interaction in augmented reality, like interaction in virtual reality, because you are dependent of the physical space.
Exactly.
For example, if you cannot move somewhere physically, you cannot move. In VR, for example, you can teleport. You have other navigation technique that could be different. So this is, I think, a big aspect of a big difference between prototyping for augmented reality and VR, the interaction and how the physical space will allow you to interact with virtual or physical content.
I see that. Okay, good. So you also mentioned diminishing reality. That is not the domain that has really extended very much, but it's kind of interesting. And you see some examples there on the right-hand side from some researchers. It's a random pick. Did you consider to making use of diminishing reality more, or? I mean, it's more out of curiosity. I'm not promoting this in any way.
It wasn't a complete direction, but this could be investigated. For example, for the versioning, because you can reproduce the content virtually and then affect the virtual representation of the physicality, but you can also hide some parts of the physical space. But this implies other constraint, other limitation, which are that you cannot get rid of the physicality of things. If you don't see something, you can still interact, unfortunately, with it.
Yeah.
So I think it's one of the limitations that let us go forward for.
So more questions, still at introduction. So here's some help. So I was acquainted with this paper and also this author some years ago. And it's actually talking about a systematic approach to this design metaphors, because you talk about design metaphors here, and it reminded me that this could maybe be a good way of systematically understanding what the system is offering, what the metaphor presents, and what is actually implemented. I mean, there should be 3 letters here. I don't know what has happened, but you can just go to the source and look at the original paper. I think it's pretty good.
Okay.
And also this work of TeamStorm and versioning. There are some further follow-ups there that you can take a look at, timelines and playing back forward timelines. Okay, and here, so we come to chapter 2, collaborative design in MR. So, yeah, I mean, clearly, if you look at AR, collaborative AR here, you see you cited this, and there's also, there are a few works showing kind of helper worker situation, AR, car repair, stuff like that. So, now this is done in Mercedes with HoloLens, as you can see 10 years later. So what would you see are the big advantages of going from tablet AR to head-mounted display AR in those 10 years? the time you have been a student partly. So you saw this come out.
I will say the main advantage of the headset is to have your two hands free.
Yeah.
And you can have,
Sure.
yeah, which is, for example, in this case, if you just have the ability to point and manipulate with one hand, can be a strong limitation.
Sure.
Also, I think there is still development to do with the augmented reality headset, for example, for the field of view. So the field of view is quite limited, even in the most recent headset.
Yeah.
And this is, I mean, you are limited by the size of the screen of your tablet, but I think this limitation can be more, I mean, it's a different limitation.
Sure.
So,
It's okay, since you already have it in there, so you maybe discuss it. Okay, and here I saw this. This came out of the demo this morning. I really liked that demo too. It just reminded me that France has had very great designers, Yusan, for instance, and the patterns he used are kind of similar to what you presented, which is simply interesting. I'm not saying good or bad or anything, but it's kind of interesting. And also a friend of mine, Marco Fatacanelli, who he's in industry now, but he did great research in graphics, and he used some Gauss-Seidel methods to do parallel graphics processing. So really cutting edge until 2 years ago, where I went to industry. And you might take some of that works, and see if those kind of real-time simulation of textiles in all their kind of richness could be a good complementary component to your work.
definitely, yes.
It would be very interesting.
Yeah, of course it will be. But again, I think right now the computational possibility with the headset is limited. This kind of simulation requires high computation, even of sometimes offline computation.
Sure, no, but it's real time. That's the cool thing. It's way more powerful than what you would believe. So have a look.
Okay.
You might be able to run HoloLens 5 or something like that. I mean, I don't know who picked up this kind of work, but very good. So here is some more, and what's it called? I follow up on some of the questions regarding. So how do you explain this for the external view in your main paper here, or the fine paper, CW paper? How do you explain that the external view is so much more difficult than the headset view in terms of correct positioning?
It's something we mentioned in the discussion of the CSCW article, the position of the camera. I also mentioned it in this presentation.
Sure.
There is this psychological, this result regarding the difficulty of performing falsely mental rotation.
Yeah.
I mean, the more you have rotation of set, the more you will take time to say, okay, so this is right, this is left, etc. So the position of the camera is something that could have bothered participants.
Okay, thank you. And I'm sure you wrote about that in the paper. I just missed seeing it, so I'm sorry for the question, but okay. And a little bit the same here. How did you find the variables? How did you come up with them? I guess you say that too, probably. I mean, these 5 variables, did they come from the first study? Because this is from the second study of the paper. Those 5 kind of.
Yes, it's similar to the first study.
Yeah, I see. So it comes from the first paper, or the first study in that paper.
Yeah.
Okay, good. Let me see if I have anything more. Yeah, a few more questions. I'm almost done now. Two more pages. Okay. You answered this at the demo. So in the bike case, you saw you mounting the bike and then remote users. So were they kind of playing customers or something like that?
Yeah, it can be.
Kind of. Mm-hmm.
Yeah.
Okay, good. So that answers kind of also the second question. And then you talked about the ectic gestures, and they might be well used. And Sven Meyer showed recently that you can do some warping and they can be even better used. But that's graphics and rendering techniques. So that's another domain. Did you think of making more use of the ectic gestures in your work? To put it that simple.
It was not a specific focus, but the idea was to maintain some deictic gesture, for example, with the stick. The ability to point true. Without having a finger to point with.
Exactly, it's one kind of gesture.
But it's not some. I mean, the future of August was mainly inspired by the result of the first study, and this was not a thing that really writes. So we
No, it's
consider
okay. It's
the feedback, but yeah, it could be interesting to
it's
see
quite a
more
niche
about.
thing also. I mean, it's something that's been coming and going the last few years. So I'm not saying it has to be, not at all. Just a question. So here's something, well, task design, you talked about it. Something that struck me a little bit, you say that you study either co-located collaboration or remote collaboration, and that's good. I mean, that's what the world is like. If we are in Brussels or Tokyo, it's still remote, so the distance. But if it's a little bit closer, say you are there in this room or that room or the room next, then there is something in between, like a dimension, kind of a maybe fractal dimension of 1.5 times away, but not 2 times away, half a time away, or something like that. So did you think something about that? Like you're a little bit away, but not really away, like next door room, next door house.
I think the distinction between remote and collocated is somehow related to the workspace awareness, because when you are not able to see your collaborator anymore, even if the collaborator is just near to you but behind you, you still need this workspace awareness. And in this term, it's a problem that is relevant if the collaborator is behind or in Tokyo or elsewhere. I think there is a kind of switch.
Yeah, there is.
Which is related to the amount of workspace awareness you perceive or you share with your collaborator.
I don't know if there's a say in French like out of sight, out of mind, or out of sight, out of XX. I don't know. But it would be something like that. Maybe explain the cultural phenomenon.
Yeah.
Well, some references and some language, but that's small stuff. So I leave it there. Thank you very much.
Thank you.
Thank you.
Thank you for your presentation
Well.
as well.
Take the stage.
So we'll now go to the supervisors. You're welcome to ask questions or share comments. So we'll start with Cedric, who's an associate professor at IMD Atlantic.
Thank you, Anastasia. So I will not have any questions. I know well your work, but I will just make a few comments. So first of all, I want to congratulate you for the presentation. I think you give a really comprehensive overview of all the work you achieved during these 3 years. It's not always easy to summarize everything in 45 minutes. Then I want to highlight that you built 2 systems that were quite complex to set up. You had to deal with steps camera, video montation, video streaming, distributed system, and really many sources of issue as a generic pointer. So I think you were very autonomous on this part, and it was really nice to be able to trust you on the technical part and really focus on the research part. About the research part, I think you have 2 nice contributions. I'm very happy about the CLCW paper. I'm a bit frustrated that we did not have time to evaluate the second contribution.
Me too.
It's like that. I really like this idea of having several versions of the virtual content and be able to create this object and use them. I think it opens many opportunities. So I have opportunities to evaluate this and push it, the concept maybe further. And finally, I just want to say that I think all this pandemic time was a very difficult time for PhD students, especially for those who have to run user studies. So I'm glad you were able to keep a good motivation, and I think you had at the beginning we had to change the focus of your first contribution because of the pandemic. You build a system to run experiment at home with your own dining table and your own bike that you bring in. I think it was very good, and you run many participants from home, so I think it's always good, and you were always optimistic about that, even if it was not very easy. So I want to thank you for that. I also moved to Brest during the PhD, which was not really. I'm sorry about that. But it was always a pleasure to work with you, even if it was remotely most of the time. I think I never had the feeling that we were so far away. So I think it's good. I hope it's the same.
Yeah, so it is.
2 conclude, I think you achieved a nice piece of work, and I want to congratulate you.
So, Stefan Sandila is next. Was that something that I here? I think it's okay.
So Cedric, you said everything.
No, yeah, I mean, I would probably add a few points.
First, yes, to congratulate you. Right? So I would say
That again emphasize the fact that at the
beginning, so you had started several months working in a study for collocated collaboration with
and then Zoom, we had to change completely our plans.
so we didn't know right at the beginning, should we not?
So we're at the-
You know, starting the other project of
Came also for some kind of things that
we wanted to see, right? We were working remotely, different
places.
had to do everything, but finally, yeah, I mean, it was hard, much harder, of course, but yes, it was a big challenge.
For you. So yes, I will also like
I have to say, right, because we were very, very easy to work with, right? Because we were very calm, very want to learn things because we
you have a background. You have an engineering. You had experience with VR and AR technologies.
but for your discovering which areas was something new, but we were very willing to learn and we were very actually very easy
Going.
So yes, so
I
probably
will have a question or something, a reflection, because
something specific. He was mentioning
mentioning something about having a computer with you, right?
while interacting with AR. But the other there's another kind of direction probably we're thinking also about, right? Because also some where you don't have your hands right to work with your
Computer.
right. You have also your voice, and there are
Some
some
applications, right, that use more voice interface, and also
you in our first study,
the first
study with others, right? Something that you observed, I remember, was that as a participant, the voice was right.
dominant, even if there was a reduced
The use of verbal communication, still
verbal communication.
was something really important, right? So
Probably,
probably, I mean, if you want to reflect on that, how you can make
that take advantage of that, right? But actually, when I was thinking about the collocating, the problem there is you have a language, right?
there's we can collaborate together, but when there are the moments that there is
Private spaces, there is also conflict there, right? If we start,
so I
I don't know if you have
something thoughts on
that whether actually there is a challenge there, right?
using the
Verbal communication as a
way to interact
act as well, right? As an interaction kind of.
point or object, and to what extent this can be challenging or not, and if you have to deal with collocation, collaboration.
I mean, if people are able to speak, I think it will. I mean, this needs to be observed, but I think it will continue even if virtual space are not synchronized. What makes me think that is that, for example, when you have a brainstorming session in participatory design, for example, there is time where each participant is on his own or on her own piece of paper and just drawing stuff without being interacting with other for the design. And yet people still continue to speak, and it's okay. And at some time, okay, people will show their drawings or not, and they continue to speak, and there is no rupture. There is no complete separation of this exchange, this communication. So my guess is that this limitation will barely be the same in this configuration, but without any user feedback, it's hard to project estimation. And at the same time, yes, also to use the voice as a way of activating tools, of interacting with content. This is problematic for the confidentiality, effectively, because you will be heard. This is something that could be considered to guidelines for this kind of application, saying that, okay, you want to design new interaction, and if you have this kind of configuration where the privacy is important, this is something to avoid. And yeah,
It's an issue, the privacy, when it's not an issue. This is something that we haven't explored, right?
Yeah, it's something to to investigate. At the end, we come back to these points. But yes, it's something to investigate. And I think my guess is that it will be similar to participatory design session, where people have their own private space with a sheet of paper and then share it with the others when it's in a good state. And this is not. I mean, it's something that is working currently in the design process. So let's hope it is also in augmented reality.
So I will go last. It's a bit hard to follow after the supervisors, but I'll do my best to ask you a few questions that are maybe a bit challenging. No, I'm joking. They're not going to be challenging. So the first one is kind of a very simple one because both Cedric and Fanny's mentioned that you worked remotely. Did you ever happen to use Argus to work, for example, to test your things with Cedric that was away?
Oh yeah, we did some tests.
Okay, so Cedric was able to test remotely things that you were doing on your own by connecting through Argus, so you could do a connection across the site.
Yes, and this was the case for all the participants with Argus. The procedure was to download a client on the participant's computer, then they execute this client, and it automatically connects with the server, which was in my home office, and I was wearing the headset, and hey, it's my home, and let's do the task. So.
Yeah, I was just wondering if you actually used it as well, where you were prototyping with your supervisors as well, kind of like eat your own dog food, not just for your participants, but you actually used it for designing your studies, etc.
Oh, for the evaluation of the study for prototyping.
For creating your study more generally.
Yes.
So my other question, I mean, I'm not sure if it's a bad or a good thing, but a lot of people nowadays work a lot on mobile phones. And I was looking a little bit at your study with Argus, so let's say the chapter 4. And I was thinking you're a remote participant, the person who controls and has a view of the workspace. I could imagine situations, a crisis scenario, for example, where you have somebody that's, I don't know, giving instructions. Sometimes they only have a mobile phone. How do you think your results from those studies would hold if the remote participant had another type of device? It could be something very small, like a mobile phone, or it can be in a crisis center, and it could be a table, for example.
To start with the smartphone, for example, the interface of Argus is mainly used through buttons, for example. So this can be used with the screen interaction. Also, the pointing technique, you can have this kind of interaction with application on the smartphone. The limitation will come from the ability to perceive details on the resolution. And this is also the case for on a screen, for example, where the frontal camera resolution of the headset will appear like limited with a high pixel and. But I think the interaction of Argus could be extended to other interaction because it's not dependent of a keyboard and a mouse. So I think it could be, but it requires further investigation.
Do you expect that some of the findings with respect to how communication was done would change in terms of the verbal communication, etc.? If you have, let's say, a smaller screen, I don't know. I'm asking for you. I don't have a hypothesis.
I think some of the aspects of our evaluation are more related to the interaction, the ability to communicate with someone which is not here and wearing an augmented reality headset. So I think these parts could be similar, and the same effect could be observed.
It's okay to say it needs to be investigated.
Yeah, I'm trying to reflect on that, but I will end on that. It needs further investigation.
Yeah, no, it's good. I was just wondering if you ever thought about it. My other question, it relates to some of Jerry's question about the versioning. I find that it's very, very cool. So you have this, your part about sketching, you have this idea of a version object, collocated, etc. And then you have the studies that are more like Tetris pieces, or building a mobile phone, designing furniture. So you actually have a lot of small pieces and multiple physical objects. How do you think you could transition from a version object that is one big object that you sketch around to tiny, tiny pieces that are coming together and have potentially their own version at one point, then they are grouped, they're ungrouped afterwards, etc.?
I think it will raise a question about the organization of the workspace, and more precisely how to visualize all the version. This is another research direction, which is not especially related to the version object or the manipulation of the 3D object. It's more, okay, I have a lot of information. How do I display it? How do I interact with it? And yeah, this, for example, the tree navigation, in 3D into clusters, etc., could be used in this case to navigate among versions. But this is another research direction.
So I have a last question. This is the last. I really like Ferran's idea of the magic wand, so I'm going to steal it now. So imagine you had a magic wand and you could go back in time and you're starting your PhD today. What would you do differently?
Prevent COVID. Too easy.
In terms of topics, methodology, etc., right? Because you learned a lot while you were doing your PhD.
I'm quite happy with the way my thesis ended to be, because I had the chance to develop system. This was my main objective at the beginning of the thesis, to be able to develop new kind of interaction, to test it, and also to be able to study it with users, to have participants, to retrieve feedback, to make some evaluation, concrete evaluation. I really enjoyed it. And also the ability to have a more conceptual approach of how to interact with things. I really enjoyed it, and so I will stay. I won't change that if I have the possibility. I think maybe still the reorganization due to the COVID, because I started by investigating collocated interaction, and more precisely how to share an object of interest between two collocated people, and to have stop this project and start Argus, and then come back to this project, and finally I want to do something else, and to have the ability to rearrange this in terms of timeline. Yes, that would be my ideas.
Very cool. So at this point, I'm not sure if the jury has other questions. Very good. So the audience can ask questions. Unfortunately, only audience members who have a PhD are allowed to ask for questions. So this is a rule of the university. Do we have any questions from the audience? No, they're all very happy with your work. So I think we can leave you and the jury will deliberate. I'm not sure how you planned this. Should we stay here? Should we leave? I'm looking at you. What was your plan? Maybe you know better. Should we stay in this room?
Stay here and then we go back.
So we'll ask you very nicely to get out of the room and stop the
Which order?
So we're starting to become experts. So after Fages defended his thesis, collaborative design in augmented reality, supporting multiple views and parallel versions of the design space in the domain of human-computer interaction and mixed reality. The presentation was very clear, well-structured, pedagogical, and very dynamic and well-illustrated. The slides were complementary to his thesis, providing a different perspective to his work. He succeeded to demonstrate a high level of theoretical, technical, and methodological contributions. His work advances a timely and strategic topic and can inspire future research and industrial innovations in the domain of computer-supported collaborative work. After Fages gave elaborate and well-argued answers to the numerous and sometimes challenging questions from the jury. He demonstrated a lot of maturity and mastery of his topic. The jury congratulates him for his work. Pour toutes ces raisons, le jury décide à l'unanimité de décerner à Arthur Fages le grade de docteur en informatique de l'Université Paris-Saclay. You have it ready, or should I give it to you?
I have
Arthur will give an oath now as a new doctor.
Also have it on the screen. En présence de mes pairs, parvenu à l'issue de mon doctorat en informatique et ayant ainsi pratiqué dans ma quête du savoir l'exercice d'une recherche scientifique exigeante, en cultivant la rigueur intellectuelle, la réflexivité éthique et dans le respect des principes de l'intégrité scientifique, je m'engage, pour ce qui dépendra de moi dans la suite de ma carrière professionnelle, quel qu'en soit le secteur ou le domaine d'activité, à maintenir une conduite intègre dans mon rapport au savoir, mes méthodes. All right, so we switch to another side to. It's okay. Thank you all of you for attending my thesis defense. There is so many people to thank. I hope I will not forget anyone, and if I forget, I will thank them later. I first want to thank you, my jury members. I want to thank Ferrand and Jerry for their insightful review during the manuscript review. I want to thank Morten and Anastasia for accepting to be part of my defense and your very interesting questions and reflection. Of course, I want to thank my thesis advisor, without whom nothing would have been possible. They teach me how to do great research, and I will forever be grateful for this gift. I also want to thank all the Ex-Situ team. Thank you, Wendy and Michelle, who are not here, but they give so much energy and kindness, and passion for RCI is very inspiring. I want to thank the permanents, Sarah, Janine, and Nicola, for being career models. And of course, thank you to all the current and former PhD and non-PhD students for having transformed 3 years of work, 3 years of wonderful moments filled with love, climbing, cakes, and beers for almost all of them. I will now switch in French, so I will first thanks. Pardon, non, justement. Je voudrais remercier infiniment Chloé pour ta patience et ton soutien. Je voudrais remercier la bande de Dinan. Il y en a certains qui sont venus, il y en a d'autres qui sont à distance, pour avoir partagé tous les moments annexes de cette thèse et les avoir rendus si intenses et mémorables. Je voudrais remercier tous les gads qui sont sur les streams et ceux qui sont venus, celles et ceux qui sont venus, pour leur amitié sans faille. Alors j'avais mis parfois loin du quotidien, mais près du cœur, mais certains sont venus, donc près du cœur dans tous les cas. Je voudrais remercier Michel et Olivier pour avoir tenu à partager ce moment avec moi. Et je voudrais remercier mon père, ma mère et surtout Ava pour m'avoir encouragé avec autant d'amour. Et merci à tous d'avoir assisté à cette défense de thèse. Merci. propose de continuer avec un premier pot qui est plus proche que le deuxième. Donc, si je ne dis pas de bêtises, ce sera dans la salle là-bas. Voilà. N'hésitez pas à me rejoindre. Sinon, il y aura un deuxième pot un peu plus tard dans Paris. Donc, si jamais vous voulez choisir votre pot. Merci beaucoup.
Merci beaucoup.
Merci à vous. Ça, c'est un challenge.